Hi, welcome to my talk. This is model-driven and low-code development for event-based systems. My name is Bobby Calderwood. I'm the founder of a company called Evidence Systems, and we make a product called ONote. So ONote is our product, and this talk is sort of a story about how we implemented one of the key features in this product that we're actually releasing today. It's ready for evaluation by the Kafka Summit audience. So please go check out onote.com. Sign up for free. You can use the product. Our goal is to help software teams to design, implement, and operate event-driven or event-based systems. So design is what we started with. That's where we started with ONote. We have this really great collaborative event modeling canvas where you can, with your team, design out, how your system works, right? That's the user journey. You see kind of the design elements in your user journey, and kind of how the state changes over time, how the user introduces change into the system, what those changes are as they're recorded as business events, how you aggregate state up to show your user what's going on in your system. All of that is sort of handled very well by event modeling. We'll have more to say about event modeling later in the talk. But design, we had that in the product. That was sort of where we started with our product. Operate is a whole bunch of platform integration. So these are not easy problems, but they're straightforward and sort of relatively well understood problems, right? We got to integrate with data platforms. We got to show visualizations, overlay data of what's going on in your system right over the top of your event model map, so that you can see, okay, in this part of my system, here's what's happening in prod right now. And we get some analytics and that kind of thing. So again, not easy problems to solve, but straightforward and well understood problems. Implement is where we had some inventing to do. We had to come up with some new art here. And implementation of event-driven systems is not easy. And kind of the goal that we had was to accelerate the implementation aspect of it. And so, that probably means code generation. That means, helping the development team automate the boring and repetitive aspects of their work so that they can be productive and work on the most interesting and unique and novel parts and business valuable parts of their system. So we looked back at the history of this problem. We are not the first to try to solve this problem, right? This is a problem that's as old as business computing. People have for a long time wanted the ability to draw a picture or some kind of model of a system, push a button, and then that system is real, right? It goes from model to running production system. And that's long been a dream. So that's as old as business computing, right? From the 60s, that's sort of been the goal. And a lot of these efforts started with these visual programming languages. So these go, again, all the way back, Smalltalk and early Lisps and that sort of thing had this very visual aspect. Visual Basic and Xcode sort of more recently. Scratch is a really great kids IDE to teach programming to kids. And these are very visual languages. And I don't have much to say about these other than, hey, these are really cool. They don't really solve the problem that we're trying to solve. All right, this isn't about building distributed business applications, transaction processing systems, analytic systems. This is really for building kind of single process space programs, right? A mobile app or a program that runs on one machine. So the state in these systems are often transient. Sometimes maybe you'll store it out to a file or whatever. But these tools are still in common use, right? If you've done mobile development in the last 15 years, you've probably used Xcode. They have a really fantastic interface designer. So there's a lot to learn from these tools, but they don't exactly scratch the itch that we were trying to scratch here. Another attempt at this type of paradigm where we go from model to running system were system modeling languages. Here, the 800-pound gorilla is obviously UML. In theory, UML was designed to do this sort of comprehensive round-trip engineering, where I could draw a picture of my system or several, pictures from different angles, looking at this system. We'd have integrated documentation right there within the model, and then we can, turn that model into code. We could actually go the other way around and turn code back into models, right? That full sort of round-trip engineering concept. And this shared model would improve system comprehension among the stakeholders, business stakeholders and engineers and everybody. In practice, it just didn't deliver on a lot of those big promises. It's valuable, right? There's some really good stuff in UML, but for the most part, this is an engineering thing, right? This is nerd stuff. Business stakeholders don't really get involved. The diagrams that are for stakeholder involvement aren't the best diagrams in the standard. So this is mostly about system level concerns, and for the most part, given when UML came of age, we're talking about object oriented programming design, right? We're talking about class hierarchies and ERDs and a lot of static stuff, right? Tons of nouns and a lot of like static. Here's what the state is at a particular point in time, and how the different aspects of the state relate to one another. There's not a lot of dynamics. There's not a lot of modeling how state changes over time. I'm sure there's tons of people who are great at UML who are like, no, he's lying, you can do this. But I'm just talking about the practice that I've seen in my career. Lots of people have tried using it. In my experience, it doesn't quite deliver. But hey, look, sequence diagrams are great. State machine diagrams are great. There's a lot of good stuff in UML that our team can learn from in the pursuit of this kind of model-driven low-code development for event-driven systems. Another category of systems, kind of swinging from the engineering side of the spectrum over towards the business side of the spectrum, are business workflow and rules systems. A lot of great systems in here, a lot of great open source software in here. There's BPMN, BPEL, these kind of open standards for how to model and then how to execute business process definitions. JBPM rules, there's a lot of really cool activity is one I didn't list on here, some really good stuff kind of on the workflow and the rules systems. REAT is an old algorithm. There's some new implementations of it that take it a little further, like Clara rules and Clojure. There's some really great rules systems to describe your business logic. However, this is about describing business logic. It's about describing sort of process flow rather than the business narrative of how state changes over time. And in my experience, business events in these models tend to be transient, and they're really just for advancing the state machine, from this state into this other state. In fact, you end up, in practice, getting lots of really badly named states like approved by management. That's a state. Is it? That's actually really an event, right? It got approved by management at some point in time. That was a thing that happened. But we tend to name our events, or we tend to name our states in these workflow systems after events. So there's a lot of bad modeling. There's a lot of sort of incomplete modeling, and the reason for that is that these business process diagrams are complex. They're sophisticated things. There's languages with dozens and dozens of kind of different symbols and constructs and things. It becomes very confusing, especially if you're a non-specialist. And initially these systems were intended for business users to use, right? Your business process specialist, they're going to come in, your consultant that you pay $1 bajillion an hour to are going to come in, they're going to diagram out your process, and you're going to have a running system. In reality, often these systems end up getting programmed by developers, right? At the beginning of the project, the consultants sell the heck out of these business process workflow and rules engines, and then halfway through, all the business stakeholders sort of disappear back to their day jobs, and the developers are left holding the bag. And now, instead of just writing a system in some Turing complete, general purpose language that they're used to using and proficient in, like Java or whatever, now they're stuck with this like DSL, and they've got to sort of program a system in the DSL. So really, it's a step backwards on a lot of projects I've been on in this using these types of systems. They end up being a step backward because now you're just hamstringing your devs from using a real language to build a real workflow system. Now you're sort of pigeonholing them into this business workflow system. Quote from Martin Fowler to this effect. This quote is about rules engines. I will extend it here. I'll take liberties with poor Martin's quote here and extend that to workflow systems as well, because I've seen similar dynamics play out. Often the central pitch for a rules engine is that it will allow the business people to specify the rules themselves so they can build the rules without involving programmers. As so often, this can sound plausible, but rarely works out in practice. And again, I would extend that beyond business rules and into the business workflow. So kind of swinging even further kind of away from engineers and towards kind of the business side, an outgrowth of a lot of these business workflow systems, but there are also a lot of purely proprietary offerings here. A lot of commercial offerings in the full stack kind of low code, no code platform space, right? And this is where, for me, this whole idea of kind of low code, no code, or model driven development takes a bit of a dark turn. I don't love this category of things. There's some great applications here. I don't want to, sort of poo-poo anything that these teams have written. There's some really powerful and very interesting systems written this way. But for me, there's sort of this bad organizational dynamic that plays out where it's like, hey, look, our IT department is slow and unresponsive and our devs aren't great or whatever. And so we're going to work around that problem by empowering this like legion of non-developer citizen coders to like draw pictures in this system that this vendor sold us. And the vendor tells us they can draw a picture and it'll just turn into a working system, right? This has a lot of the same drawbacks as these business workflow systems where it starts out being citizen coders, but eventually the IT department ends up holding the bag here, right? The IT ops department gets stuck holding this thing that is effectively this black box, right? It's this proprietary runtime. It doesn't work the same way as all of the apps written in real programming languages, Java and that sort of thing. It doesn't follow the same security practices. It doesn't go through our CI/CD pipelines for auditing and compliance and security checks and all that kind of stuff. So every step along this value chain, you're relying on this vendor, and hey, they're there early on when they're making the sale, and then they become increasingly unavailable, right? So it's really easy to get going with these systems, right? It's easy to draw a picture and get something working and in production, and it's good enough for a minute, and then you hit a wall. And if you want to scale this system to something that instead of 15 people in your department using every day, 15 million users are using every day, boy, it's going to punish you, all right? If you work outside the well-trodden path that this low-code system is designed to solve, it's going to punish you, right? If you try to integrate with systems that it doesn't want to integrate with or doesn't have a plugin for or whatever, boy, it's going to be difficult. So these systems are easy to get going, and then eventually you hit a wall, and then IT ops is left holding the bag and operating this thing or trying to scale it or rewriting it from scratch in a real programming language or something. So it's not great. So this is my sort of least favorite category of these things. On a brighter note, there's some new good stuff happening in this world here, right? We've got these things that are model driven. They're not necessarily visual. They're more declarative and data oriented. And a lot of these are targeted at describing and defining our web services definition, right? The interface definition. So we've got WSDL, kind of old and clunky, but still works great, and it's all over the place. OpenAPI Swagger for the REST people, GraphQL, gRPC. A new entrant here is Async API, which is designed to describe non-synchronous, not synchronous request response, but asynchronous message-oriented protocols, including event-driven and event source protocols. It can describe those rather effectively. So these are cool. They don't scratch the whole itch because these are really about describing communication protocols. This is about, what messages do we exchange, request responses, that kind of thing. It doesn't really have much structure or opinion around how you manage your state over time, right? This is just about how do we broker the transient communication protocol for communicating among distributed actors here. So these are great for defining pieces of your technical infrastructure and for automating certain aspects. There's some great code gen built up around these things. WSDL's had code gen in every major programming language for like 25 years, right? So it's good stuff. But it doesn't scratch the whole itch. This isn't about applications. This is about communication protocols. We've got some really cool new entrants in the wireframing space. So kind of building on that legacy that I talked about with Visual Basic and Xcode and so forth. Now we've got a lot of systems that are just about the UI UX design, right? They're not about the whole program like Xcode might be, where you define your interface, but then you also hook in a bunch of code. This is just about, what does it look like? What does it feel like? What's the styles? How big are the buttons? And what colors are we using? That kind of thing, which are super important. But they are starting to build kind of this limited code generation capability where I can, export a React component or export a pile of HTML and CSS, which is great, right? That's much better than nothing. So there's some really cool stuff happening in the space. There's also a new and kind of emerging group of schema-driven UI tooling, especially around forms. So, the forms are a lot of the state in your app is managed in forms a lot of the time. And there's a increasing use of schema-driven tools for these forms. So my team's trying to solve this problem, but what has changed in our operating environment that would justify a new approach to this? So I've just outlined a whole bunch of really smart people who have tried to, crack this nut for a lot of years. Why a new approach? Well, what has changed to justify kind of taking a new angle at this model-driven and low-code development approach? So from our perspective, we see a handful of important things that are happening here that justify, maybe taking a new look at this or a new approach to this model-driven and low-code space. The first is sort of this need to understand the customer journey. We're moving, digital transformation is like the marketing buzzword to describe a whole bunch of different dynamics that are happening in the industry right now. A lot of these applications that were designed and implemented, 20 years ago were around a specific channel or specific department or specific, use case. And so they all had their own kind of database, and they all, lived in different parts of the organization or were owned by different departments and that kind of thing. Right back in the old days, when I wanted a pizza, I would call up Domino's or Papa John's or whoever, and I'd talk to some teenager on the phone, and the teenager would punch in the order into their order system, and then they would sort of execute the order from there. And then I would, as the customer, would just wait. And 30 minutes later, a pizza may or may not show up at my door, and maybe I have to get on the phone again and yell at somebody, right? So that was kind of, these systems were designed for use by agents of the company, employees of the company, not for use directly by customers. So think bank tellers and, that sort of thing. They were designed all these initial banking applications for the bank tellers to use because the customer's going to be speaking to the bank teller. We're moving to this world now, especially accelerated by COVID, where we're reinventing and repurposing these business capabilities that are encapsulated in our applications, and we're exposing those directly to the end user. So now when I want a pizza, I don't call up anybody. I don't talk to anybody. I get on my mobile phone, I punch in my order, I hit pay, and then they continuously update me about what's going on, right? If I were to call that, Domino's Pizza location, or if I were to call company headquarters, they would be able to find my order and say, yeah, hey, here's the state of your order right now. It's in the car, it's on its way to your house, right? So now all of these different applications that used to have their own little data store and used to be sort of channel or department specific, now there's this strong motivation to move all these things into the business event log, right? This is a Kafka conference. We've probably all read Jay Krebs's fantastic little book about the log and its value. Having this streaming data, this data in motion, rather than point in time data stored in a database, a relational or other type of database. Now we have the business narrative stored on this business event log. And what comes with that is not only can we understand our customer's journey, across channels and so forth, be able to understand them. Now we can start to build predictive models for their behavior. We can anticipate their needs. We can know what they're calling about before they call, which is really great. Again, I come from a banking background, and back in the old days, you talk to a bank teller and then you go home and call someone in the customer service center, and two different experiences, right? You have to explain your problem all over again to both people because their systems didn't talk very well. Now the customer expectation is, if I'm on my mobile device and I deposit a check but it doesn't go through, I call the customer service person. They should know what's happening and they should be able to pick up right where my problem left off. In the morning, I go to the ATM and check and see if that deposit landed. And if not, I go into the bank and I talk to the teller. And each time I do that, my expectation as a customer now is that all of these systems are talking and I don't have to re-explain my problem 4 different times for these 4 different channels, right? So this common sort of omni-channel view of our customer and their journey on this business event log, and the ability to use analytics on this journey to understand our customers better. These are just par for the course now. We have to be able to do this in this new digital world. We also have this strong need for real time. So we can't just do this, a day later or a week later on a batch basis. We need to do this in real time. I don't need to sell this to all of you. You're here at a Kafka conference, right? This is what Kafka is all about. But being able to notify our customers, hey, your pizza's in the car, or your mobile deposit just landed. To be able to make decisions on the fly, credit worthiness and other types of decisions. Being able to do analytics and machine learning in the back end, not on week old or day old or hours old data, but on real time data. And then being able to integrate our systems and data in real time. These are all important concerns that we have to be able to handle, right? So those are the major pressures that are sort of, hey, maybe we should take a new look at this. We're designing our applications differently. Maybe we should take another look at this kind of low-code model-driven development. Some other factors in play here. Polyglot persistence. Now there's not just the database that we model in UML with our ERD. Now we have the databases, right? We've got different databases for different purposes, for different data access patterns and different use cases. So we need to be able to handle that. There's been a resurgence of functional programming ideas. I come from a functional programming background, especially in Clojure and other Lisps. And a lot of functional programming ideas are coming back into the fore. That pendulum's kind of swinging back away from OO purism, kind of back into functional programming territory. And that's a good thing. Functional programming tends to be a better fit for modeling distributed computing than object-oriented programming in terms of a mental analogy for distributed computing. It's heavily influencing UI development. We have these components now that are sort of functions of the data that they require. They emit events. All right, this is very sort of functional reactive state management pattern built up around things like React. You've got Redux and Flux and all these other things. And there's some useful ideas coming from domain-driven design, CQRS, event sourcing, event storming, event modeling. These are ideas that are coming from the domain-driven design community that are worth a look and maybe have an important bearing on this low-code model-driven development problem we're trying to solve. So in short, there's this sort of emergence of business event-based application design rather than business sort of current state application design, right? Current state is how we've designed applications for quite a long time, but really event-based application design is a much better way, and it's a much better future for all the reasons that we've discussed here. So yeah, maybe it is worth a look. Maybe it's worth another look at this kind of low-code model-driven future. What do we need? What does my team need in order to be able to generate code for our customers, within our product? Oh no. Well, we need a model for describing how state changes over time. So we need to understand kind of the big model, the meta model that encapsulates kind of the whole application, how state changes over time. Got that. Event modeling, we'll talk about it here in a second. We also need an extensible schema language for describing data. So data, at rest, views of state, read models, how do we present state to our users, but also how does state change? We need to be able to describe the events. How do we transfer data in our communication protocol with commands and read models and queries and that kind of thing? We have to be able to describe all these different aspects of our data world. So data modeling doesn't go away. It just sort of changes and gets much more focused than just ERDs or class diagrams or whatever. And then we also need some set of suitable output targets, right? What are we generating? Are we going to generate runtime language, Python or Go or Java or Clojure or JavaScript or whatever? Or are we going to output some sort of intermediate representation, like some of the things we looked at earlier, SOAP, WSDL, or OpenAPI Swagger or GraphQL or whatever. So event modeling is awesome. My talk last year at Kafka Summit was on event modeling. Please go back and check out that talk. I do a really deep dive into what event modeling is, what it has to offer to this world of event-based application design. I think it's fantastic. I didn't invent it. This is from Adam Dimitrik. He's a close partner. We work really closely with Adam and his team at Adaptech Group. And event modeling is really fantastic. With 4 simple constructs, we can describe a whole application. Interfaces or wireframes, that's what the user sees and touches and experiences. Commands are the blue sticky notes. They represent requests for change to be introduced into the system. Do this thing for me, please. Events represent state changes, right? A thing has been done. And then read models represent aggregations of these events into useful views of state that we can then present to the user for further action or decisions or whatever. So with these 4 simple constructs, interfaces, commands, events, and read models, we can describe really any information system. What's really cool about this is that it focuses on state change over time. So rather than getting into the nitty-gritty of business logic and branching conditionals and all that kind of stuff, or rather than diving really low level into system concerns about how do I organize my source code files and my classes and my hierarchies and that kind of thing, it focuses on state change over time, which is the most important and business valuable aspect of the application. There are explicit patterns in event modeling for integrating with external systems outside of our control, right? For importing state from those external systems and for exporting our own state back into those systems. So it's built to play with others, which is great. User experience design is first class, right? That user experience is a huge part of the sort of digital transformation, right? We're designing applications for end users whom we can't train and who are not going to read our documentation. So we really have to design great experiences for them. We have semantics around our data transfer objects, right? Now, data transfer objects in a lot of systems are just these sort of like dumb containers that you schlep around and they don't really mean anything other than just like, well, my compiler says that I have to have something to put these data into to stick into this other thing. Now our data transfer objects are semantic, right? A command has a specific business meaning and it's got a schema and we can describe the data in it. Read model, same kind of thing. Like when we're showing data to our users, we have semantics around those things. And then finally, business logic within an event model fits very clearly into very few limited places and specific types of business logic. And when I say types, I mean type in sort of the ML, functional programming sense, right? I have function signatures for each one of these sort of places in the model where business logic would be required. So this is great. This is really good from a code generation, low code model-driven development perspective. Event modeling, a great place to start. We also need a schema language. This one was really hard. We looked around at a whole bunch of different schema languages that fit our requirements, right? It has to be neutral. We have to be able to output to a bunch of different languages and formats. It can't be so programming language specific that it fails to target, the broad range of output targets that we need. It's got to be powerful and flexible. We have to be able to describe a wide variety of data structures and do useful things with the schema, like generate sample data and certainly validate, examples of that data coming back, right? So it needs to be powerful and flexible. We need to get a lot of mileage out of requiring our users to model these things in schema. We should provide them a lot of value in exchange for that. It's got to be serializable and transmittable, so probably data-oriented, because they have to be saved as a part of our core event model. And extensible, we need to be able to extend these things to fit new use cases, compose pieces of the schema language together to answer new needs and requirements and output targets. We found one. It's great. It's called Molly. It's based on a lot of ideas from Clojure and Clojure Spec and other things, but it incorporates a lot of learning over the last 25 years from different schema languages, from XSD and XML, JSON schema, kind of all the way up to the present. And then we need a set of suitable output targets. What makes a good output target? Well, a lot of those things that I didn't like about these sort of full stack low code environments or low code, no code kind of environments, it's got to be DevSecOps friendly, right? You got to be able to check the intermediate representations into Git, right? It's either got to generate real source code or some sort of text-based format so that we can check it into Git, so that we can integrate with our CI/CD pipelines, so we can do our security checks, do our audits, as we change this thing over time. It can't be a black box. It can't just live in some database someplace. And I don't know, what's the current state of the thing? I don't know, go check in the database now, right? There's no history of the changes or versions or anything like that. It can't work that way, right? An output target needs to be programming language neutral. We need to be able to reach a lot of different languages and frameworks from one particular output target or set of output targets. So this gets us to the question of intermediate representation versus runtime code. Do we generate Ruby or Python or Java or Clojure, or do we generate some intermediate representation that already has reach to these programming languages? We chose, for a couple of reasons, to generate these intermediate representations, like so here in the middle tier, the web service interface definition tier, gRPC via Protobus or Avro, GraphQL, OpenAPI Swagger. These are intermediate representations that are in broad use. They have really great code generation capabilities that target that intermediate representation. So we can reach a lot of languages by generating one format. And furthermore, these interfaces, these interface definition languages are useful on their own. Having an API gateway that's got all of your Swagger specifications in there is useful, because then you can generate clients and you have this sort of living documentation of what your communication protocols are. So these are very useful on their own, and we think superior to generating runtime code directly. We're going to at least initially target these intermediate representations. The other important thing is that we cover the full stack, which is what the slide's really about. We need to be able to generate stuff for the UI, for the client-side development. We need to be able to generate web services definition stuff, and we need to be able to generate backend sort of event processing code for processing events and building read models and that kind of thing. There's some great stuff. We've already talked about a little bit of it. Figma and others have some HTML and React kind of generation capabilities. There's some great code generation around gRPC and GraphQL and even OpenAPI and Swagger. KSQL and KSQL DB. KSQL is a great intermediate representation, right? We're at a Kafka conference here. Generating KSQL is awesome, because that's sort of generating this intermediate text-based language that then essentially compiles down to Kafka streams and manages all the stream processing. Generating async API is another really interesting possibility, because you can generate something that describes a whole asynchronous sort of message or event-based workflow and event processing layer. And then, of course, we want to be able to integrate with the Confluent schema registry. So being able to output event schemas, what we're actually going to stick on the Kafka topic or whatever, we want to be able to generate Avro, generate protobufs or JSON schema or something that is going to target and integrate well with the Confluent schema registry. So how does it all come together? I'm proud to announce that ONODE does have code generation capability. We can generate Avro protocol to target gRPC, that web services interface definition tier. And we can output event schemas to integrate with the Confluent schema registry. So I'll show you a demo here of how that looks in ONODE and how we solve this problem. So check out our demo now.
To begin our demo, we'll create a new ONODE event model and import a model we built previously. This is a model of the real-world conduit application, which is a common example application that is basically a medium-like social blogging CMS. The real-world backend specification defines several data structures such as a user, a profile, a tag list, an article, and a comment. We'll define these as model-level schemas, which can be referenced for reuse by the entity-level schemas that we'll define in a moment. For example, here we define a user entity as a map with email, username, token, bio, and image keys. We can validate a sample user JSON object against our schema to check our work. Next, we'll define several entity-level schemas for the publish article command. We define schemas for each of the following roles within the publish article command: an Avro request, which we define here on screen, an Avro response, and an Avro error schema. Here we see them defined. Note the reuse by reference of several model-level schemas, such as tag list and article. Finally, once we've defined schemas for our various entities, we can generate Avro code. We generate a zip archive containing an Avro protocol file that defines the RPC interface for our commands and read models. The generated archive also contains Avro schema files for our events, which can be used with the Confluent schema registry. One use of the Avro protocol file is to define a gRPC client or server. Here within a Micronaut Java application, we use the Avro Maven plugin to generate Java classes and interfaces, enabling our IDE's code completion functionality to wire up our publish article command handler. With ONODE's Avro code generation, we're able to generate the network messaging protocol and data serialization concerns directly from our event model, freeing up developer time and attention to focus on the business logic for processing this command. Avro code generation is the first of many well-supported intermediate representations that the ONODE team plans to target in the coming months. Please visit onode.com today to sign up and learn more.
So in conclusion, model-driven and low-code development are worthwhile, and we wanted to take another crack at this. We thought it needed a refresh for modern constraints and modern practices. Don't pursue low-code development with the goal of replacing your dev teams. I think that's a bad path, and it's probably going to end the same way it's always ended, with the dev teams using these tools that you intended for your business users and your ops team holding the bag on something that they don't love working with. So instead, find a platform and a framework. Hey, maybe it's ONODE, I hope it is, that will accelerate your development with a robust model, shared mental model, but also code generation capabilities that will allow you to target these robust open standard intermediate representations. That will facilitate fast flow of features from inception kind of into production. You need to get feedback from ops. That is sort of our operate features that we're working on soon. So we're going to get feedback from operations so we can inform the development process, what needs to be built next, what needs to be made better. And then we're going to sort of all along the value chain facilitate communication, build good shared mental models. Event modeling is great for that. But also goals and incentives to make sure that we're perpetually learning and making this team, this whole product team of business stakeholders, graphic designers, software engineers, architects, ops people, this shared sort of cross-functional team is going to be delivering value rapidly and continuously learning, right? That's a much better end goal than just trying to get to a quick win with some sort of low-code, no-code platform. So it's a worthwhile goal, but make sure that you use it in the proper way. Thank you.